Hey everyone, what a week it has been. A couple of weeks ago, after the Quen 3 release, it felt like things were slowing down. We had a couple of weeks of relative quiet, but then that all changed this week with Google I/O 2025, where they released Gemma 3N and Gemini 2.5 Flash, which I did a video for. And in Anthropic today releases Claude 4 Sonnet and Claude 4 Opus. Let's quickly take a look at the pricing. As you can see, Sonnet is $3 per million for input, 15 for output, and Opus is 15 for input and 75 for output. Clearly much more expensive than comparable models, including 2.5 Pro and 4.1. Now, Opus, for those of you who don't know, is the largest model they've released so far. They had not released Opus 3.5 and 3.7 like they did with Sonnet, so I figured this should be interesting. Now, Sonnet 3 had already topped all of my tests, so most of what we're doing here is to ensure there is no regression with Sonnet 4. And indeed, Sonnet 4 keeps top scores on all tasks. So that got me excited, thinking we might have a new champion. But then I did the complex OCR task, which is a test that very few models can even score past. I think the highest score is like 81% or something. And I was a bit disappointed. So let me show you why, and we'll go through all the tests in this video now. Before we continue, I would like to ask you for a favor. As you can see, we are a very new channel with a small number of subscribers. So if you enjoy our content, please consider subscribing. It costs you nothing and it helps us grow. Also, check out our website promptjudy.com. You can sign up and create your own custom evaluations, or you can look at community evaluations for a wide variety of use cases. We have published hundreds of evaluations and are releasing more every week. If there's one thing that you take away from this video, please let it be that you should be testing your own prompts with your own data to see what works best for your use case. Prompt Judy helps you do just that. Now, back to the video. So the first test we have is the harmful question detection test. This is a classification test where the model has to classify a question as either harmful or not harmful. Let me show you the prompt. We tell the model that you're an AI tasked with identifying whether a question is harmful, manipulative, or attempts to elicit an inappropriate response. We ask it to check for harmful intent, manipulative structure, inappropriate content. Then we ask the model to see if the question is trying to leak system instructions, or if it's probing for operational guidelines. Then we give it a list of false positives. Then we give some additional guidelines. And finally, we ask the model to respond with just the word harmful or not harmful. Now, there are other options to detect harmful questions. Most model providers have content filters, but sometimes you have custom nuanced rules that you want to apply. A prompt like this helps in a situation like that. In fact, we use a variation of this prompt in production for our customers. What you see here is not necessarily the best prompt, but I did want to show you all these other models that have scored a perfect 100% on this test against the same dataset that we're about to test. So this is the score for the harmful question detection test. Both of them score, pretty much perfect 100. Opus decided not to answer this question, which is why it's losing 5 points, but I wouldn't count that against Opus. I wouldn't use Opus for this task anyway. Much smaller models do perfectly fine with this test, so this is really a task for a much smaller model. But for all intents and purposes, Sonnet and Opus can do this just fine, which is no surprise. So the next test is the named entity recognition test. This is a structured JSON extraction test, and the instructions are as follows. You are a specialized named entity recognition system. Your task is to process input text and extract specific entities with the following rules. We tell the model to extract people, keep the names in the original language, locations translate to English, organizations translate to English. We do this because the location and organization is used to populate an SQL query, and the data is stored in English. We tell the model to follow the specific requirements for people, extract and separate first and last names, ignore middle names. For locations, break it down into city, state, and country. We want the country code to be in ISO format. For state code, we only want US and Canada. For all others, we want international. For organizations, we want to remove legal entity terms. We want to handle multiple entities. We want to correct any misspellings. We want to preserve the original language for person names. The evaluator here is a JSON evaluator. So it compares the model's output to the expected output recursively for each attribute in the JSON. Even if a single attribute is wrong, the score is 0. So this is a very strict test. A couple of years ago, even the best models scored below 50% on this test. But today, as you can see, multiple models score above 90% on this test. So, as you can see, both models score a 95% on this test. In fact, I think this is the highest any model has scored on this test. This is a very difficult test. I think Gemini that we tested yesterday or the day before also scores a 95. I think 4.1 scores a 95, but that's the highest any model has scored. Let me show you a couple of small mistakes that the models are making. In this case, honestly, I could have gone either way. The instructions do say that we should be translating the name of the bank, which is what Opus has chosen to do here. But in reality, this is actually a real bank name. So either response should have been right. So ideally, this is a 100% score, I think. And again, this one, I'll let you be the judge. We do ask in the instructions to correct the spelling, and it has decided to put the apostrophe here. Again, this is very much an edge case. I would have given a pass for both of these in this case. So I think these models score as close to 100 as possible. So I think overall, even looking at some of the other models, the mistakes that other models have made, these are the least egregious of the mistakes. So I believe these models are among the best, if not the best, for this complex, difficult task. So now this is the SQL code generation test. The prompt is as follows. You are a specialized SQL query generator system for SQLite database. Your task is to process input text and generate a valid SQL query based on the provided schema. Then we give it the following rules. Generate select statements only. No insert, updates, or deletes. Return not allowed for DML. Return not possible if the question can't be answered. Only reference the table letting system the schema. Respond only with the SQL query. Respond with appropriate joins. All data is stored in English. We give it the following schema, and then we give it the question, and we give it some examples. The evaluator here is a code evaluator, so it actually runs the generated SQL statement and compares it to the output, to the expected output. So this validates that the SQL is not only syntactically correct, but also produces the desired results. And again, a lot of models score a perfect 100% on this test. Claude Anthropic has always been strong on this test, but now with 4.1 and the reasoning series from OpenAI, they're also catching up. And then there are open models like DeepSeek and Qwen that also do very well on this test. So this is the SQL code generation task. There is absolutely nothing surprising here. Sonnet 2.7 scored a perfect 100 on this. Sonnet 4 scores a perfect 100 on this. Opus makes a small, I won't even qualify this as a mistake. We ask for the number of albums, so we want a number in the return. Opus chooses to give me a data set of the albums that match the criteria. I would have gone either way, but because we have taken away points from other models for this small mistake. Unfortunately, Opus does get a 95, but this is as close to 100 as it can get. And also, this is another one of those things where you don't really need Opus for this. Sonnet 4 with its abilities is perfectly fine with this. As you can see, it scores a perfect 100. It's much cheaper, much faster, and it's perfectly capable of handling very complex. And I should show you some of these. Some of these questions are very, very complex questions. Like, look at this. This is complex SQL. So, yeah, I feel these models are more than capable of handling this. And then the final test is the Retrieval Augmented Generation test. Let's look at the prompt. You are a specialized AI assistant tasked with answering questions based strictly on the provided context. Follow the following rules. Use only the data within the given context to answer the question. No outside knowledge, assumptions, or information not explicitly stated in the context. Respond in the original language. Include citations, the format of the citations. If the question is completely unrelated, say, I cannot answer this. If the question is somewhat related, provide the relevant information from the context, respond in Markdown. And then we give it the format, then we give it an example, and then we ask the question. One of the biggest things that we're trying to look for in this test is how the model handles trick questions, questions that are about things that are not in the context, or questions that are tangentially related to the context but do not have an authoritative answer. We want the model to follow instructions and say it can't answer the question rather than providing a wrong answer, or an answer that is an opinion, not a fact based in the context. I have found that some of the reasoning models struggle a little bit here. But again, there are a number of traditional non-reasoning models that do quite well on this test, both open source and commercial. So, again, no surprise. This is the Retrieval Augmented Generation test. Both models score a perfect 100%. Sonnet made a very, very small mistake where it chose to put the reference incorrectly. So it says it cites the reference as 2, where in fact, and the reference list, it's making 1 over here. I think this is a very small mistake, but that's why it's losing a small percentage. But overall, these models are perfect for this task. It's pretty easy for them. So again, nothing surprising here. But the surprise is coming up after this one, so stick around for that. So to the final test of the video, this, I have to warn you, is a pretty difficult test. In fact, no model has scored over 85. I think the highest score is somewhere in the low 80s on this test. What we're trying to do here is we're trying to convert pages of PDF documents into LLM-friendly HTML. So when you have a PDF document, something like this, what you want to do is, on ingestion, run it through a strong model that can convert it to LLM-friendly HTML that looks like this and maintains all the information as represented on the page, visually in charts, tables, or whatever. So in this case, this is a chart from the Total Energies financial report. We're asking the model to convert this chart to an HTML that looks like this. Let me show you a few more. This one is a page from the financial report. It has complex tables. We're asking it to convert to simple tables like this one. So these tables we can pass to the LLM at inference time. If a strong model ingests these at ingestion. So this is the PDF document. This is the corresponding HTML. Let me show you a few more. This also is a report with charts. This also is a visual report. If you look at this, it's representing a timeline. You want to convert it to a table. Same with this one. This is also a financial report with lots of complex columns and so on and so forth. There's quite a few more I can show you. But at a high level, the task is to take a snapshot of a page of a PDF document and convert it to HTML that we can then pass on to a smaller LLM for inference. So this is the test where I feel Claude has disappointed a little bit. And maybe I went into this with very high expectations, given everything that we're reading about Claude 4. But for those of you, if you remember, I tested Gemini 2.5 Flash a couple of days ago. And as you can see, it's scoring 73 when Opus 4 and Sonnet 4 are scoring much lower. And this is after, if you remember the pricing, Gemini 2.5 Flash is actually a fraction of the price for Opus, from Opus and even Sonnet, right? So let me show you some mistakes. This one is very simple. It's actually, if you think about it, it's actually a very simple ask. We're asking the models to look at these charts and transcribe them into a table. Let me show you what Gemini has done. Gemini, by the way, Gemini missed this as well. And what Gemini has done here is it has swapped the values for Europe versus Middle East and North Africa. Europe is supposed to be 3790. It made Europe 3398, which is the value for Middle East and North Africa. So this is the mistake that Gemini is making. Let me show you what Sonnet has done. Sonnet, interestingly, has chosen not to respond at all. If you look at this, all it has done is it has transcribed the numbers correctly, I may add. However, it basically just puts the labels below it. Doesn't really make a table, doesn't try to associate the numbers with values. And then let me show you what Opus has done. Opus has done something similar, except it has completely ignored these numbers. So this is why they both get a very low score on this question. So this is another example where Opus and Sonnet are clearly underperforming Gemini. So let me show you. Basically, what we're asking for is to transcribe these tables. You can see 122364, 122364, 233740, and so on and so forth. As you can see, Gemini does this perfectly. The entire table is transcribed correctly, including very small and confusing figures. Now let me show you what Opus has chosen to do. As you can see, it says other 12 and then renewable 23, which that gets right, but then it gets 64 for natural gas. I don't know what it's trying to do here. The information here doesn't quite make sense. We want the numbers to be separated between 2023 and 2030. Clearly not happening here. And I think it's missing some numbers as well. Across the board, it just seems to not get this. Let me show you what Sonnet has done. Again, I think it's very similar. If you see, it's getting these numbers 23%, 23%. I don't know how it's missing these 12%, 64%. There's lots and lots of mistakes here. So as you can see, Gemini seems to do a much better job at this task, which is really disappointing and a bit surprising given how much cheaper Gemini is compared to both of these larger models. As you can see, this is a much, much better result. So here's another issue that all three models missed. So let me show you the first one. This is Gemini missed this. As you can see, the expected value for cash equivalents at the beginning of the period is supposed to be 16,196. And in the actual response, it is 14,189. Which is surprising because you would think that if it were having a problem reading, why would it read 6 as a 4 and then 8 as a 1? These are surprising things. These are things that I wish I could go inside the brain of the LLM to see why it's making these mistakes. But Opus also makes a similar mistake. As you can see, for depreciation and amortization expense, it says 17,730 when the expected is 17,729. Again, this is such a weird mistake. right? If it's unable to read, why is it reading 30 as a 29? And a similar, very interesting mistake that Sonnet is making, the change in financial services receivables for 2023, the actual response shows a -9, but we're expecting a -8. Again, why is it reading one number off using vision? I can't explain it. There are more issues, and I can go in and try to demonstrate to you, but I think at a high level, the point I'm trying to make is the models are getting better and better, but this is one of those tests where I'm not seeing incremental progress. As you can see, for all of my other tests, models are doing great. For this one test, I just don't see any model really hitting a very high mark on this test. What is a bit more disappointing is the Claude 4 series of models. I had a higher hopes for, because 3.7 did pretty good on this test as well. I was hoping for incremental progress on this test from the Claude 4 series, but maybe next time. Who knows? So hope you enjoyed this video. If you did, please like and subscribe, and I will see you in the next one.